Welcome to my YouTube channel, Learn to Teach Mission. Don't forget to subscribe my YouTube channel. In this session, we are going to see Matplotlib.pyplot. It's a Python package used for visualizing a data in form of graphical plots, charts, figures, and animation. As we all know, data visualization is an effective way of communicating information to others. Data visualization is one of the important steps in both data science and machine learning for analyze the large amount of information to discover trends and pattern. Okay, and there are many libraries used for data visualization. Some few popular libraries are Matplotlib, seaborn, and bokeh. Matplotlib it is widely used pure Python data visualization, and the seaborn it is used for generating informative statistical graphics. It also built upon top of Matplotlib, and basically it is used for examining relationship between multiple variables. And the last one, bokeh, it is used for generating interactive plots which can be accessed as JSON, HTML object, or interactive web application. Basically, this package will use to build some interactive graph in the websites. A quick introduction about this session. Anatomy of figure. If you search Matplotlib anatomy of a figure, then the first search result from Matplotlib, if you click that, you will find the anatomy of figure. We will see in detail in the coming slide. And the next, creating a figure. Here we are going to see the component which are required to build a figure. And then some types of graphs which are available in the Matplotlib, like line plot, scatter plot, bar graph, horizontal bar, pie plot, and histogram. If you click example section in the Matplotlib library, you will find different type of graphs which are available in the Matplotlib. If you click any of this icon, that will redirect to the source code of that graph. By doing hands-on on this graph will help you to understand this syntax. Okay, will help you to understand the remaining graph which are available in the Matplotlib code. Okay, and then Matplotlib style. Here we are going to see some of the style component like font color change, font size, and many more are there. We will see in that section. And the next two section, subplot and subplot using GridSpec, we are going to create multiple graph in a single figure. Like here is the example. A same figure contains four different graphs. No more theory, let's get started. Anatomy of figure. Here is our site from matplotlib.org. Anatomy of figure. The outermost line which represents a figure. Okay. And then major ticks, minor tick, y-axis label, x-axis label, title, legends are the component are used to build a figure. Those component we will see in the section creating a figure. Next, grid, color, label color, title, style, and fonts are the Matplotlib styles where we gonna see in the section Matplotlib style. Fine. At last, we are going to see the some type of graph. Here, the line graph and this dotted are the scatter plot, line plot and scatter plot. This we are going to see in the section line plot and the type of plots. Okay, let's do the hands-on. As a first step, we all have to import matplotlib.pyplot into our Jupyter notebook by using import command. Import matplotlib.pyplot as plt. Plt is the alias name for matplotlib.pyplot package. Next, we have to create figure. Here is the anatomy of a figure. The outermost line represent figure. To do that, I am going to call pyplot package class figure, figure. and assigning it to the variable fig. Inside the parenthesis, you have to define the axis of this figure, x-axis length and y-axis length, by using fig size given 2 comma 6. 2 is the x-axis length and 6 is the y-axis length. After that, you have to define the axis. Ax is the variable for the figure fig. Actually, this line is used to partition the entire figure into different section. Like here, see, this entire image is a figure. Inside that, there are 4 partition: 1, 2, 3, and 4. To do that, we have to create 4 different axes. Here, we have to create 3 axes because the entire figure partition into 3 different sections. Okay, let me visualize this partition concept in Jupyter Notebook. Here, first I'm going to create a single partition in a single figure. We have already created a figure. Now I'm going to add subplot figure dot add subplot. Inside the parenthesis, you have to mention row, column, and then position in the array. As of now, we are going to create one partition. So one row, one column, and the position 1. Plt dot. Here I am going to use plt function show to display the figure. Here is our figure because we have defined only one row, one column, and one position. If I copy and paste 2 more, then you will see 1 row, 2 column. Here I am changing the column to 2, 1 row and 2 column. And the last value is the position. Now we are going to have 2 graph in a single figure, which means 2 partition. Then you have to define the position for the second axis 2, and then differentiate the axis with different variable. Here I am going to use axis 1 and here 2. Okay, and click shift enter. You will see 2 different one row and 2 column. Let me change the axis of y to 4. Here you could see. And here also I am changing 1 row, 2 column. If you copy and paste 2 more axes, P and 4, the entire array I am going to have 2 comma 2. So only we can see 4 different partition in a single figure. Position 1, 2, 3, and 4. Here is our figure. Inside the figure, we have defined 4 different partition. Okay, fine. And the range 0 to 1, it's a default one. Everywhere you can see. Here 0 to 1 and 0 to 1. This value we can able to change it, but we will see in the next section. I hope this will give you some insight about the how to create a figure and how to partition the entire figure into different section. Let's move to the next section. Different option for creating a figure and plotting a data. Actually, there are 3 different types of method available for creating a figure and plotting the data. There are many more, but let me give you some insight about these 3 methods so that you can refer which one you feel something easy to grasp easily. Fine. The method 1. First, you have to import, then it's fine. We already imported the Matplotlib into your Jupyter notebook in the previous cell. The next one, you have to create figure by using plt.fig. This one which we already seen in the above cell, so no need to any description for this line. Fig size for defining a axis length 8 comma 6, and then axis This line for partition a figure fig dot add underscore subplot and then one row, one column, and one position. Here is the method start. You have to set title, X label name, and Y label name, and X limit. It's the range. The default range we have already seen in the above cell 0 to 1, but here we are going to change the limit based on our case, and then Y limit. To do that, I'm going to call the function axis function ax dot set. Say that if you click shift tab, this will populate some information where you could see some additional parameters which help us to set some values. Here it's not defining in the Jupyter notebook, but I will give you those keywords. Title. The first one is title. My first plot. The next one, X label. All are small. You don't need to worry about the case sensitivity. Label X axis and then Y label is equal to Y axis. Then X lim is the limit for the X axis 0 comma 5. You can define based on yours, but I'm going to give both X lim and Y lim. Limit is 0 comma 5 comma Y lim equal to 0 comma 5, and then plt dot show. Yeah, here is our first plot. Let me toggle the header so that you can clearly see both cell and graph. The title is my first plot. Here is our title, and x-axis is here and y-axis, and the limit 0 comma 5. The default one is 0 to 1, but now we have changed by using the option axis dot shed function. Now I'm going to plot some data into the figure. Going to create some dummy variable to array 1 comma 2 comma 3 comma 4 comma 5, and then y is equal to 2 comma 4 comma 6 comma 8 comma 10, and I'm going to set this value into the axis by using function plt. Inside that x comma y is the dummy value, and then same. If you click shift and enter, you will see the line, because we have the x limit value 0 to 5, but here you could see we have used dummy value up to 10. So you have to extend the x and y limit so that you can see the entire data plotting into the figure. I'm going to change the x limit to 10 and y limit to 10, and I'm going to change the axis size so that it will be sync and you can see both cell and graph in a single page. 6 comma 6. Here is our entire 10 comma 5. Here is our 5 value in the middle, and 5 also you could see all other data plotting into this figure. The only different you could see in the next method is here, the plotting the data. Method 2. Method 2 is almost similar to the method 1. I'm going to copy this entire line from here to below. Here we have used different keyword for the function set, but in the method 2, we are going to use different function for each keyword. For example dot set underscore title for title, and next ax dot set underscore x label, x axis, and then set y label for y axis, ax dot set underscore x lim 0 comma 5, x dot set underscore y lim 0 comma 10. Yeah, also 0 comma 10, and then you just remove the line. If you click shift enter, you will see the same image. Axis subplot is something is missing here. Sorry, here I made some mistake. X lim, same result. This is method 2. The only difference is the method 1 we have used a single method set. Inside that we have used different keyword for title, x label, y label, and x limit and y limit. But here we are using different method for each keyword, title, label, and limits. Let me see the method 3. METHOD. Method 3. It is the easiest method among others. And it almost similar to the method 2. So I'm just going to copy the entire line from method 2 and pasting it here. Remove the axis from here. Instead of calling the axis function, I'm going to call package function. Matplotlib.pyplot package alias name PLT. And then function title. You just remove all the prefix set underscore and replace axis with PLT. And click shift enter. You will see the exactly the same result which we see in the method 2 and 3. Okay, but one of the biggest drawback in method 3, we can't create more than one partition in a figure because the axis concept which we have already removed. So there won't be options to create more number of partition, but we have a different option to create a different partition in a figure. We will see those things in the upcoming section. Among these three methods, I'm going to use method 1 throughout the remaining section. If you feel something different in the method 1, then you just pick some other method 2 and 3, and practice the remaining sections on your own. Okay, fine. There won't be any issues. It's almost similar, but there are some little bit syntax difference. So don't be worried about these methods. But at the end, you have to create the same result, same as that of other methods. Okay, fine. Let's move to the main section. In this section, we are going to see some different types of graph, type of graph. The first one, line graph. Let me add header for this line graph. I'm going to copy the method 1 because we are going to follow the method 1 throughout the remaining section, and changing into the line. The default plot is line, so there won't be any changes required for this method command lines. But there are some attributes which are available to make more visualize the line graph. For example, color, color is equal to CREAN. The line color is changed to green. And then style, line style, style, the dotted line. See, dotted line. And then line width, line width equal to 3. The thickness of the line is changed to the width of 3. The last one, marker. Oh, this will help us to identify the plotting data point. See, 5 different points are plotted in this graph by using the value x and y. This is line graph. The next one, bar graph. Let me add header for that. BARGRAPH. I'm going to copy this entire line from line graph and place it here. The only small change is instead of plot, you have to give bar and remove all this keyword. We will add some different keyword for this. You just click shift and enter after removing this keyword and change the plot to bar. You will see the bar graph. See how simple is it? Let me add some attribute to that. The first attribute, color, color equal to red. And if you click shift enter, the bar color has changed to red. The next attribute is width. Width is equal to 0.6. This will change the width of the each bar. Okay, if you just change to 1, you will see some difference. See, the width is changed to the value 1. Let me change it back to the value 0.7 so that each bar graph will be separated each other. And then the next keyword, edge color, color, black. See, the edge of each bar is colored with black. Okay, if you click shift tab, you will find the available attribute options. Okay, height, width and bottom. If you scroll down below, you could see there are many more. Line width, text label. You can try it on your own based on your requirement, and this will give you some insight about that. Okay, you just try with different other parameters or attributes with bar graph. The next one, horizontal bar, HORIZON, horizontal bar. The syntax line is almost similar to the vertical bar. You just copy from the above cell and place it below, and then just remove all the attributes and add H, bar H, which represent the horizontal bar. Just click. Okay. Some of the attribute like color, COLOR, it's available for this horizontal bar. CREN. Also, you can add the edge color. See, the border color is changed to black. The next graph is scatter plot. This one is almost similar. Just copy the line graph. Okay, line graph and place it below and change the plot keyword to CATER, and then remove all the attribute which we used for the line graph, because there are some different attributes are there for the scatter, but you just after removing these two and you just click and shift enter, There is no caps lock. All are case sensitive. You just need to be take care that. Okay, you got it right. Scatter is the dotted graph. There are some attributes are there. Let's check. Color COLOR equal to green GREEN, and the color of this data point is changed to green, and then marker 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 equal to it's a circle. This will up arrow. Okay. So that there are different types of attributes or parameters available for each plot. If you want to know, you just Google the word Matplotlib and then the plot, SCATTER, scatter plot. If you want to know any other different plot, you just add the plot name here. Okay, scatter pie line plot, and then you click this one. This will show us the parameters. Okay, here is our marker. You can pass different marker value, and then alpha line width. Here also you can pass line width, edge color. Okay, so these are all the available parameter which you can pass in the scatter function. Fine. The next graph is pie graph. PIEGRAPH. In this session, I'm going to show you how I learned the new thing from the Google, from the internet. Okay, pie graph. You just search the keyword Matplotlib pie chart. Okay, you will find n number of search results, but you just choose the one from Matplotlib.pyplot.org because it's the official package Matplotlib package website. You will find some description and the parameters which are available to pass inside the pie graph. At the end, you could see some example. Okay, here are some of the example. Let me show you some basic pie chart example. You just click that icon. This will redirect to the source code page. You just copy this entire line from here to your Jupyter notebook and take shift enter. You will see pie chart. Okay, here what they are doing, they are assigning the labels frog, horse, dog, logs, and then size. Out of 100%, they are partitioned into 4 different sections. 30 plus 45 is equal to 75, 90, and then 100. And they are exploring some piece of slice. They are exploring the second slice. This one. Okay, fine. And then figure, they are creating same as the figure, and then they are calling the function for this axis pi, and then they are passing some attributes to that. If you remove this attribute, click shift enter, you will see some basic pie chart. Okay, and then add one by one each attribute. You could see before and after so that you can easily understood what are the changes are doing for each parameters. Now I'm going to add the explode alone. This will explode the slice 2, and then see the second one is exploded, and then again I'm going to add label. This will add the label for each size. See, frog, logs, dogs, and hogs. Now I'm going to add percentage. The value I'm going to display it in the pie chart as a percentage format. For that I'm going to add auto pack. It's a percentage. And removing that comma. See, each value are representing in the percentage format. And then the last 2 attributes are shadow and angle. This one will add the shadow on each slice, and the last start angle will show the 90-degree rotation. If you just click shift enter, you will see it's just rotated to 90 percentage, and then the slice 2 will exploded out of other slides in the pie graph. Okay, fine. This is how you have to follow the steps to learn new graph from the Matplotlib library. See, we have seen only some of the syntax in the above pie chart. Now I'm just copying the entire line from the Matplotlib, how we understood each. By doing this way, we can explore many more graphs which are available in the Matplotlib site. So I'm just showing the way how we can explore each graph available in the Matplotlib. You can follow the same method to explore more graphs and try it on your own. Okay, fine. Here we are going to see grouped bar chart. This one is almost similar to the bar chart, but here we are going to compare two column with a single column. For example, the comparing quarter one, quarter two car sales in the year 2011. Okay, this is the use case. Let's check some other example in the internet. And if you search the Matplotlib group bar chart, you will find the result from matplotlib.org. You always have to refer the matplotlib.org. Okay, here they have provided some example. You just copy this entire line and paste it on your Jupyter notebook and click shift and enter. You will find the grouped bar chart result. Let us check the syntax. What they are doing here, they are importing packages at the top, and then they are creating labels G1, G2, G3, G4, G5, and then they are having two different array, men's and women's. Okay, what they are going to do here, they are comparing men's value the first position and the women's first position, which means the index 0, and comparing with G1. Okay, here these two are integer, but the label has a character. We can't use character to plot the x-axis. So what they are doing in the next step, they are converting the labels to integer format. If you just print this one, you will find what they are doing here. They are converting into the small one. I put it capital X. You just replace the word small x. See, 0, 1, 2, 3, 4. Because G1, G2 is the label, but the value which is used to plot in x-axis are 0, 1, 2, 3, and 4. Okay, whenever you create some value for plotting, then that value should be the integer. If you want to that in character, you can use the label concept and convert that label to integer value by using np dot arrange, and then the width of each bars. Okay, the width of each bar. Then what they are doing on the next step, they are creating figures and axes on the same line by using plot dot subplot functions, and then they are using two different value for men's and women, rex 1 and rex 2. Okay, here see what they are passing. Label is men and woman, and the width is same for both the graph, and what the which value they are passing, men means and woman means. Here they are using x-axis, the entire x-axis divided by 2, which means the overall width is 0.35, but they are dividing into two sections. Okay, fine. The first half for the men and the second half for women. Let me visually show you. See, the entire length is 0.34 because they have provided the width is 0.35. From this width, they are partitioning the first half for men and the second half for women. See, first half for that they are subtracting the value. Fine. And then they have this one you have already known. They are setting y label, title, xticks, and xticks label and legends. This one you haven't seen before because xticks is the value. Okay, this one is xticks labels are they are changing the value to label G1, G2, G3. See, if you remove this one, you will see 0, 1, 2, 3, and 4. If you want to show the actual label, then you have to pass set xtics label and with the labels. Then the each integer value replaced with the respective value G1, G2, G3. And then this one is nothing but to differentiate each color at the top of the circle. This is called the legends. Okay, if you remove this one, you will see that will remove the legend. Small rectangular box will be removed, and this will x-axis. And then this one for auto label, they are populating the label on each bar top 2025. For that they are using some logic. You just remove this one. At this moment this one is not required. If you want, you can just put it as it is and find it based on the value, because they are calculating from the rect. Okay, see, rect. Rect is the value and they are calculating it. Fine. You just remove this one and click shift enter. See, this is how you will get the actual grouped bar chart. We will see this one in the advanced section. As of now, this is will give some insight about how to explore the chart from the matplotlib.org. If you want, you can use this entire logic to put some value on the top of this bar. If you don't want, you just cut this code. You just remove this code from this line and shift and click shift enter. You will see the grouped bar chart. Okay, fine. And the next one, histogram. Histogram. If you search the keyword matplotlib histogram graph, this is how it looks like. Okay. For that we need some huge number of value. For that I'm going to use numpy array. Fast import package numpy as np and generating random value up to 100. np dot ran random dot. Okay, this one for result reproduce, because np dot random n will produced based on the pesto code. So every time when you run this cell, the under array will vary. For reproducing the same value multiple time whenever we run the cell, I'm going to use np dot random dot seed. Okay, and then x equal to, here I am going to use the value 60 plus 10 into np dot random dot ran dn. Inside that you have to pass the number of count 100. Okay, let's say the outside. Okay, and then figure fig equal to plt dot figure. Figure, this one we have already seen. Inside that you have to pass the figure size for x-axis and y-axis value 8 comma 6. Okay, the next line axis ax equal to fig dot add sub dot that one row, one column and position 1. And then set. Inside that I am passing title keyword, distribution of students percentage for histogram graph. Okay, percentage, and then y label and x label. X label is equal to count and y label is equal to count. X label equal to PR and and the function ax dot east x plt dot show. That's it. You just click shift enter. You will see the histogram graph. See how it looks like. Print x. See, it's a 1000. Okay. Value we are used to plot the histogram. I hope this will give you some clear idea about how to create the histogram graph. If you want, you just search the keyword Matplotlib histogram graph. You will find the result from matplotlib.org. Okay, if you click this one, this will redirect to some documentation where you could see some example. Here some examples they have provided. What they are doing here. Here also they are using numpy random n. Inside that they are passing some 10,000 1 lakh value for generating random numbers, and then this one we have already seen in the pie chart. On the same line they are creating both figure and axis, and then each axis they are calling to is and passing bin value. Okay, if you just click copy paste this line on your Jupyter notebook, we could see this similar result. See the similar result in the histogram. Okay, fine. At last we are going to the last topic. Okay, where we have seen the index. Yes, here is the index. So far we have completed this topic and only the subplots and subplot using GridSpec. Subplot which we have already covered. See here, using axis, different axis, you can create different subplot on a same figure. Okay, you just copy this one and paste it in below. Here are the subplot for partition on a same figure. What I am going to do now is I am just copying this line from above and placed it on each subplot. For example, I am just copy this entire one and paste it here, removing the figure line and axis and ax1. Okay, inside that passing ax1 and replace all ax to ax1 and remove this plot dot show. And if you click shift enter, the first partition will show the line graph. The likewise you can copy and paste one more like pie. Use this one pie chart and placed it below and use the axis ax2 and remove the figure. You just remove this line completely and add ax2 and here ax2 and remove this one and shift enter. See here the second one, position 2 has changed to pie chart. Now what you have to do, you have to remove this partition with some other like uh, histogram or grouped bar chart or scatter plot, horizontal bar or a single bar. You can use this any of this cell logic and replace this sub bar. Okay, now you understood, right? The only different is you have to use different axes for plotting different values so that each axis will populate different gaps on the same figure. Okay, fine. The last topic, grid spec. GRID SPEC. Grid spec. This one is almost similar to the subplot, but It's a different method to create multiple partition on a single figure. I'm going to refer my reference notebook where I have created for myself. Okay, you just copy and paste this one. See, import GridSpec. This is the package you have to import for creating a different plot on a same figure. And then this one is same line figure plot dot figure. In that figure, we are going to create 3 into 3, which is 3 row and 3 column. Okay, fine. Now just run this cell first. You could understood. Okay, see, for the first entire row, they are displaying, yes, same graph. What they are using, GridSpec 3 row 3 column, which means 3 1 2 3 and 1 2 3. It's a column. Here what they are doing for the axis one, they are calling the starting position, and here the end axis position is slicing complete column, which means 0 1 2. If you remove this one, you will see. If you want, you can copy and paste this entire line one more time. You could see only one, for example, 2 3. Change the row 1 and 2. See, 1 2 3. This one you will see. And then if you want to create a 3 graph on the 2 row, then you have to copy and paste this one and row 1 row, but the column is starting position is 0 and ending position is 0. And then here starting position is 1 and the ending position is 2. Here the starting position is 2 0 1 2 and the ending position is 3. If you click, see, 3 different graph. Now you understood, right? It's a slicing. This is a row, this one is column. Based on your requirement, you have to modify the starting and ending position so that it will partition different portion for in a single figure. I hope this will give you some insight about the grid spec. Once you created this one, the same method, whatever we see in the subplot axis, you have to use this logic here for plotting. Change the axis. Okay, and don't forget to change the axis name because this will override the each graph. If you have different axis name, then each axis will give you some different graph. Now I'm going to call using axis 1. See here, if you want to change the different axis, change the axis to AX5 and this will populate, sorry, here A5, here too you have to change A5. See, likewise you can use different axis for plotting a different graph. I hope this grid spec concept will give you some insight and the idea to explore more in that. Thank you. Don't forget to subscribe my YouTube channel, Learn to Teach Mission. Thank you.